All right, I think I'm going to get started with the introduction that, frankly, no one's been dying to hear. But starts, we have some time, of course, for the content we're all looking for today, and to give our presenters and participants more time for questions at the end, hopefully, too. So I want to say good afternoon. Thank you for joining us today. My name is John Delmas, and I'm the director of the Michigan Chemistry Council. I want to welcome you to this synthesis informative webinar on facility mechanical strategies to reduce the spread of pathogens. Today's webinar is presented and sponsored by our tremendous partners at Fishback, a firm that offers expertise in architecture, engineering, and environmental sciences. Facility design and operation, including mechanical systems, has always been important and always an area that Fishback and others have worked on. But just in the last few months, we've seen how a global pandemic that has hit Michigan fairly hard can present new challenges for keeping your employees and customers safe and productive. And as essential critical infrastructure, the business of chemistry that our members represent has played a key role in the production of goods vital for both COVID response as well as basic human needs. And so our companies have largely continued to operate. Of course, we now know that this virus is going to be with us for a while, and that pathogen spread will and should always be an important consideration, no longer something we can overlook or take for granted. So we hope that this webinar will help you better address these challenges, and we are very excited to have two expert presenters to share more. Ted Perrin is a professional mechanical engineer with 15 years of experience in HVAC design, energy work, and building assessments. And he's worked on systems for laboratory, industrial, education, and office facilities. So the whole range of areas that our companies would experience. And he's had numerous technical responsibilities for those mechanical systems. Mark Zudeman has over 35 years of mechanical HVAC design and energy analysis experience on retail, commercial, industrial, and institutional projects. He's been heavily involved in projects for design and verification of LEED and Energy Star rated facilities. And Ted and Mark will be first sharing some very informative content at the beginning, but then plan and would like to have some interactive Q&A following their presentation. So if you're familiar with Zoom, please use either the chat or Q&A features at the bottom of your screen to submit those questions for us to review at the end. And with that, I'd like to again thank our presenter and our sponsor at Fishback, and turn it over to Ted to take it away.
All right, great. Well, thank you, John. Appreciate the opportunity to do this and be here. And I know you introduced us, but I just wanted to also capitalize on Mark Zudeman here. He's one of the best engineers around, and he's extremely knowledgeable and thorough. And in the last several months, he's particularly continued his research and just expanded his knowledge here at Fishbeck. And he makes the rest of us here a lot better. And I think today his knowledge is definitely going to benefit everyone. So today we'll briefly go over several more advanced ideas, but what we really want to focus on later in the presentation is the practical applications where you can get good bang for your buck. And it's the tried and true measures that will be good, and really not just for COVID mitigation, but beyond as well. And so here's some of the points that we'll cover. And then, as John indicated, we'll open for questions at the end. What's interesting today is that if we gave this presentation 5 months ago, Fishbeck would be probably about the only experts out there. But today we're presenting to really an entire audience of COVID-19 experts. And I guess the medical doctors out there would say, yeah, how does it feel? So there's a lot that we don't know. And that's a line that we've all heard lately. We just don't know. We hear that all the time. But if we step back and consider what we do know, then I think we'll see there's quite a bit that we can work off of. We have a good foundation, and so we'll briefly touch on that, and we'll get right in, and we'll try to focus again on the practical steps that you can take, and then give you ideas about how you can reduce airborne disease transmission.
All right, thank you, Ted. There are different ways pathogens can be transmitted: through the air by short-range large droplets, or smaller droplets that evaporate and can remain airborne for some time. Other ways include surface contact, also through water and food, physical contact, and other routes such as mosquitoes. Today, Ted and I will be talking about airborne transmission because it can be impacted by HVAC systems. Now, the virus enters the body mainly through the nose and causes respiratory tract illness, therefore the SARS name. Corona comes from the outer spike proteins, crown appearance. Coronum and corona are the Latin and Spanish terms for crown. 2 represents the second SARS outbreak after the first that occurred 17 years ago. And the respiratory disease they were all aware of is COVID. Now, the virus requires a living host cell to function. It's basically genetic instructions wrapped in a fatty shell. The spike proteins lock into receptors in our healthy respiratory system cells, so then they can transfer their genetic code and take over a host cell, allowing replication to occur. Now, we've all heard about these droplets. Now, respiratory droplets are larger than approximately 5 to 10 microns, which is about the thickness of a spiderweb thread. They are known by other names as indicated. They are water droplets produced naturally by air passing through the moist upper respiratory tract during sneezing, coughing, talking, singing, laughing, even breathing. They can contain infectious agents, however. Respiratory droplet transmission is the primary mode indicated by the World Health Organization and the CDC. Due to their weight, they generally settle fairly quickly, within about 6 feet, which corresponds to current social distancing guidance. Now, airborne droplets are smaller than 5 microns, and they evaporate very quickly. They also have multiple names, but aerosol is widely used. The remaining lightweight dehydrated airborne particle is approximately 1/30th the diameter of a human hair and can travel longer distances. They are subject to temperature, relative humidity, air movement, and electrical forces. These lightweight particles can be carried by slight air movements that occur during basic activities such as walking, opening doors, temperature differences in rooms and between rooms, and by heat rejection plumes from computers, TVs, appliances, and even the human body. So, the big controversy about airborne transmission. Aerosol scientists and epidemiologists feel strongly that it's occurring. Others in the medical community don't think it's occurring because they say if it was, many more staff would be getting infected. ASHRAE says it's likely occurring and provides mitigation strategies that we will discuss. There's a lot of information that we're going to present today is from ASHRAE. ASHRAE is the American Society of Heating, Refrigerating, and Air Conditioning Engineers, which started 126 years ago. ASHRAE is a global professional society, and its members focus on building systems, energy efficiency, and indoor air quality. They are an industry leader in research, standards writing, publishing, and continuing education. Early on, they developed an epidemic task force in response to COVID, and they currently maintain a COVID-19 website that provides specific information for various building types, including reopening guidelines.
Okay, now we realize today there may be a wide range of understanding of mechanical systems for those participating. And so we thought just a quick overview on types may help you think through what you have in your facilities. One of the main concerns for today is ventilation air and where it comes from, and then whether that air is central or more localized. Your central systems, they're going to include air handling units, rooftop units, and that kind of thing. And with those, we want to think about things like, do you have full economizer capability? Meaning, can you bring in 100% outside air and not recirculate? How is your return air configured? One of our clients, for example, has a high level of filtration in the return air path only, and then a lower level of filtration in the outside air. What's the configuration of your filter bank, and what filters can your unit even accept? Now, you may have some type of system, like a DOAS unit, where as far as ventilation, it's central, and you're bringing in air in one spot and then distributing it to spaces. What's interesting here is that air from a single zone is not shared or mixed with air from another zone. And this point was brought up with one of the school districts that we're currently working with regarding their classrooms. So they see that as a real benefit. And then, of course, you could have unitary equipment, such as a unit ventilator shown here over on the right. It could be VRF, unit ventilators, again, fan coil units, heat pumps, and so forth. But where does your outdoor air come from? Do you have outside air dampers with each unit or a central DOAS, as we just showed? How are dampers controlled? Can you adjust their positions from a central control interface? And you'll see here, I put some typical manufacturer specifications up on the screen. And you'll notice that there's options for MERV 8 and MERV 13 filters, both at just 1-inch thickness. And Mark's going to talk more about this in a moment, but filtration in unitary equipment is something to consider. And there's trade-offs there with, or there's differences between what you can do in smaller unitary equipment and then usually your larger central air equipment. So these are the kinds of things that you want to consider. And then I throw this in here too. Some of you may have heating and ventilating systems that are essentially just bringing outside air in, heating it, dumping it into a space. Much of what you can do with this kind of configuration comes down to your level of controls. There is a level of customization for your specific system, whether it's this or one of these other ones or even something else. But I just wanted to get you thinking about what it might look like for you to apply the strategies that we talk about today to what you have in your building with your equipment and your systems.
All right. Engineering controls that are available to mitigate exposure include ventilation. How much outdoor air do we provide for contaminant dilution? Air distribution. How is air moved in spaces? Are there better ways to supply, mix, and remove conditioned air to reduce exposure? Filtration, mainly about filtering particles. And another tool is disinfection. And ultraviolet light is the method that ASHRAE most strongly endorses. Other methods are being discussed as possibilities. And finally, humidity control, which also relates to HVAC system operation. Now, ventilation dilutes contaminants to increase exposure time required to contract an infectious dose. Becoming infected with a respiratory illness is similar to being exposed to a toxin. There's a certain amount of infectious material that we inhale before we have a high probability of getting an infection. If we lower the concentration, it takes longer, and that adds protection. Ventilation works well, but it's energy intensive. However, the infection doses of SARS-CoV-2 isn't even known yet. Researchers are currently studying this. Also, we need to look at air removed from spaces. They need to flow from clean to less clean building areas. And also, some HVAC equipment isn't designed to handle increased outdoor air. So dilution isn't possible without significant changes. Now, air distribution is also a mitigation strategy. Airflow patterns determine the contaminant path in a space. Many items need to be reviewed in an HVAC air-based system. Location, quantity, and type of supplier diffusers, supply airflow rate and discharge velocity, reviewing both heating and cooling system operation, location and quantity of heat sources in the room, locations of contaminant generation, and if these locations are known, can exhaust grills be located there? A room layout and airflow obstructions impact air distribution. Recent plexiglass shields that are being installed to reduce respiratory droplet transmission may be actually doing more harm for airborne transmission, as they could impact room airflow patterns, creating contaminant buildup in certain areas. Also, we need to check if there are strong air currents that distribute larger droplets beyond the range that they would normally settle out. Are there pedestal or personal fans in the breathing zone, or unitary HVAC equipment that produce high velocities, which have the potential to distribute larger size droplets over a longer distance? Filtration can remove airborne contaminants, but it's only effective if air is recirculated in a space, and the space has to have particles. So ASHRAE 52.2 defines filter efficiency using MERV values. ASHRAE currently recommends upgrading to a MERV 13 filter. The upper shaded rectangle in this graph shows that MERV 13 rated filters and higher provide 90% filter efficiency for airborne sized particles. Now, this figure is from an economic analysis developed in 2013 for influenza. The study used an infection model to show that infection risk can be impacted by filtration and ventilation. Increasing filter efficiency corresponding to higher MERV ratings reduce the infection risk with relatively small annual cost change, shown with the heavy black line. The colored curves for ventilation show that it takes more annual energy to achieve the same infection risk reduction as the filters provide. The study indicated that MERV 13 and 14 filter ratings provide low infection risk at the least relative cost. Now, MERV 13 filters, there are relatively inexpensive MERV 13 filters in the marketplace, but they have reduced thickness and typically have an electrostatic charge that attracts particles, which quickly insulate the coarse fibers, which then allows particles to pass right through the filter, reducing efficiency. In addition, more frequent filter changes are required with electrostatic charge filters to maintain their MERV rating, which increases their life cycle cost. Filter inspection is advised as ASHRAE research indicates that small gaps between filters should be eliminated if you want to maintain the intended filter efficiency. Also, filter size issues shown in the left image should also be addressed. The ultraviolet light disinfection is used for many, many years. The wavelength of UV light breaks chemical bonds in the virus RNA so it can't replicate. Testing on past coronaviruses indicate good inactivation results. There are two system types used in HVAC. Surface treatment is the most common, and that's used in moist environments where mold forms, which is typically at the cooling coil and the drain pan surfaces. And then there's airborne treatment, which is obviously getting more recognition now, which inactivates pathogens moving in airstream. This requires more UV light intensity as particles pass by quickly, which therefore require more UV lamps. Now, humidity control is another measure. There is a potential for humidity control to reduce risk. ASHRAE has included this figure in their handbook for many years, which indicates 40 to 60% is the recommended indoor relative humidity range that spaces should be in to protect ourselves from IAQ risk. And they include everything from infectious diseases to chemical exposure. Recent studies show that 40 to 60% range reduces viral infection risk since droplets evaporate slower and settle out faster, our mucous membranes are less receptive to infection, and the virus is less infective in this range. ASHRAE cautions about maintaining too high of humidity for risk of moisture damage or mold growth. Now, if you're interested in the virus decay rate at different conditions, you can check out the Department of Homeland Security's Science and Technology page as shown in the bottom image. They provide calculators for both surface and airborne decay.
Okay, that's great information. But now the question is, what do we do with it? And what should we be looking to implement? Now, there's different measures you could take, and those will range in cost and complexity, and it's going to vary based on your system type, maybe whether you can implement it in-house or if you have to hire things out, and so on. There's many questions that need to be asked, and we just threw some of those up here. But again, we really want to leave you with simple things that you can do. And as we go, think about what these might look like for your facilities. Okay, we have these next strategies organized as good, better, best. And we want to start with the simplest measures first. And so here we start with control system review as being one of the most basic things that you can do. In a moment, we're going to talk about ASHRAE 62.1 standard for ventilation. But even without looking into the details of that, it's good to start checking your control system. And to that end, just a few points of consideration I'll run through. Are your ventilation schedules separate from your heating and cooling system schedules? And these don't always match up, right? So you see the schedules there on the upper left. Those schedules for equipment may not necessarily line up with the ventilation system schedules. Your primary heating and cooling equipment may be operating, but is your outdoor air also being introduced accordingly? And so what we're really going for with these basic control checks is determining if we're ventilating as we normally should. In our experience with existing buildings, over time, your systems will have moved far away from what they should be doing. And we see that all the time. It's very common. Okay, so along with looking at schedules, it's good to pull up trends, and just a quick sample there in the lower left. First, though, to that point with the trends, look at them if you can, but you may not have those set up. So take a look in your control system, see if you have them set up, and then use your judgment as far as what points are available for you to trend in your control system. But I would start with outdoor air temperature and humidity, and then damper positions for outdoor return, mixed air dampers, fan status, speed, and then outdoor airflow rate if you have it. But this lower left chart is interesting because at first glance it looks okay. The lower darker blue line represents a single distributed heat pump. And so it's really one zone of air conditioning. And you can see it cycling on and off. When it goes up, it's on, and down is off. And then above that, the lighter blue line is a ventilation trend. And that's a dedicated outdoor air system that's associated with that unit. And so it looks pretty good. But then when you look closely, you'll see that on each end of the occupancy of the heat pump, the ventilation looks like it's starting a little bit later, and then it's shutting off a little sooner than the heat pump is shutting off or going into unoccupied mode. So this could be a problem. It may not be, but it could be. And so you might want to extend the ventilation schedule, or at least look into it a little deeper and understand what are the actual schedules there and what do I need to be doing, and maybe how do I need to adjust those schedules. Okay, you can also review control damper operation and keep it simple to start. Just basic checks: are your dampers opening and closing when they should? Check your temperature and particularly relative humidity if you have it. Now, humidity is not usually going to be an issue in summer operations, since most facilities will fall in that 40 to 60% range that Mark talked about during the cooling season. But when you get into the heating season, which is going to be here before we know it, that's when you'll want to recheck for particularly low humidity. And honestly, if you don't have humidifiers, you're going to be less than 40% unless you have some extenuating circumstances where you have moisture being added internally in your building, at least in Michigan climate. But if you do have humidifiers, check to make sure they're working, and you can look at those trends and just see if they're operating and make sure the set points are good with those, and try to get them up closer to that 40% range if you can. We'll look at cost, relative cost in a minute too, so you can maybe see what that might do with increasing your humidity. But interestingly here, the control system graphic that I've got, actually I can use my mouse, this is depicting energy recovery, and it's an air-to-air energy recovery module. With the potential increases in ventilation airflow that you'll have, you want to make sure that energy recovery is working properly. Now this particular type doesn't cross-contaminate airstreams. They're completely separate, so that's a good thing. But one thing to check when you have, for example, heat wheels, is the seals between supply and exhaust airstreams. And that's a typical point of wear as the wheels spin. And just like filters, there can be large enough gaps for exhaust air to leak into the supply airstream. Now, it's probably a low quantity, but it is worth checking. And in some cases, I've seen where seals are completely missing and then need to be replaced. And then as part of your ventilation systems, it's also good to just check your exhaust fans, make sure they're operating, and that the controls are in line, again, with the supply. So we could spend a great deal of time talking about all the specific checks you could go through, but I think the main idea I want you to come away with is, if you can get someone with a reasonable level of building knowledge and control system knowledge to pay attention to what your systems are doing and how they operate, with a particular focus on ventilation, then you'll be in good shape. Okay, if you can do nothing else, you should definitely spend time paying attention to your control system. But really, in addition to that, it's better if you can get out and put eyes on your ventilation systems. What do your outdoor air intakes look like? Your dampers may be open, but are bird screens plugged up with debris? What is the location of your intakes with respect to outlets? For normal building supply and exhaust, 10 feet of separation is minimum. That's not a lot, but also you would want to take note if there's any local conditions that could cause exhaust air to become entrained back into your building. And that does take a level of judgment. As we said, it's good to at least check your controls, but it is better to physically look at the controlled devices themselves. And when we commission buildings, I'm personally a firm believer in putting eyes on things. I think you got to look at it. And dampers may be signaled open and commanded open, but are they actually open? So you should confirm that actual damper positions at least roughly match the signal indicated on your control system. You can also check to see if filters are installed properly. Some filter banks have retainer clips that need to be in place. Otherwise, the filters can easily fall out, particularly if the fan shuts off and you lose pressure. Other filters slide in and there's seals on the ends that can be missing. Mark showed a good picture of filters that were mangled on the ends because they just weren't the right size or crushed, and then you have air bypassing and it can be a mess. But all of these things are not uncommon. So want to check out the filters. We're actually actively doing work for a client on a number of buildings where one of the tasks for us is to specifically review the filters because they have a contractor who's supposed to be taking care of the filters, but the owner is suspecting that all the work is not performed as it should be. So to continue here, ASHRAE has developed a pretty good inspection checklist, an epidemic conditions in place checklist. And this is a public document. I would recommend looking at it, referencing it. Anybody can access it. It covers checks for air handling units, rooftop units, heat pumps, steam systems, even plumbing, electrical, and so on. But one specific item I'll mention is that in this document, ASHRAE recommends outside air dampers be wide open at least 4 hours before reoccupation. So as people are coming back to work and getting back into offices, and if you haven't done that yet, then getting dampers open ahead of time. And it's really a one-time flush out mode, so you can do it manually because presumably you could watch conditions during that flush out and make sure things are stable and good. And then after a flush out, they recommend putting systems back into occupied mode for at least 24 hours before occupancy. So get them running, get them going. So it'll allow quite a few air changes during that period, but also it's a good opportunity to identify if you have problems with systems that have been sitting idle for a while. Okay, so if you do one thing, look at your control system. If you do two things, look at your controls and physically inspect your equipment. And then the next step would be to actually quantify your ventilation rates, which brings us to ASHRAE 62.1. Okay, what is ASHRAE 62.1? How do you apply it? We just have to give the brief overview here. But right from the standard, the purpose of this standard is to specify minimum ventilation rates and other measures intended to provide indoor air quality that is acceptable to human occupants and that minimizes adverse health effects. It goes on to say the standard is intended to be used to guide the improvement of indoor air quality in existing buildings as well. So one thing I want to emphasize is that ASHRAE 62.1 standard for ventilation and IAQ has really set the standard for a long time. Mark was mentioning ASHRAE being around for more than 100 years. So there's times that we can look beyond basic minimum airflow rates, but from my personal experience, I've seen this where many buildings, you can, even just getting to meeting minimum ASHRAE 62.1 thresholds is often an improvement. And then once we achieve those minimums, we may want to start increasing outdoor airflow rates when it makes sense in a good way. So how do we comply with ASHRAE 62.1? Well, to fully meet the standard, we would run the numbers to determine outside air quantity and total air quantity delivered to each space. And among other variables, 62.1 factors in numbers of people and square footage to then come up with a minimum outside airflow and therefore a minimum total airflow as well. Now, it does take a bit of effort to run the numbers for a building, but calculating ventilation rates on a space method is not too bad. I would say depending on your system type, the part that likely takes more effort would be a full rebalancing of your building, where you actually have to measure airflow centrally and at every zone. So there are ways, though, that you can simplify using good engineering judgment. For example, you could divide up your building into space types, determine square footages, and then occupancy counts for each type, and come up with an approximate CFM per square foot required of outside air. Then you can actually, what you might do is actually measure total outside air and total supply air at your central system. And then finally, you can take sample readings at the zone level and then see how your measurements correlate to the calculated theoretical air quantities. Okay, so that was a lot of detail there. I wanted to put this up here. This is from an ASHRAE 62.1 calculation. There's a standard spreadsheet that could be used. And the calculations and methods of verification really depend on system types, what amount of information is readily available, and then making decisions about how accurate you need to be. It's best to verify ventilation air is properly delivered to each space. So actually making sure that that amount is going where it needs to. But even if you don't get a full verification, it's still a good idea to make sure that the central system is introducing enough air to theoretically satisfy the zone requirements. Okay, so if you look at the spreadsheet, for example, at the top there, Joe's office, right? You do a pretty quick calculation and you see that, okay, Joe's office needs 20 CFM of fresh outside air and 80 CFM total. But then down at the bottom, you have total air handling unit flow rate. So how do we make sure Joe's office is within range? What we would want to do first is at least make sure that our system is bringing in the right percentage of outside air. And ideally, we would verify that with actual flow measurements. Now, once you've done that, if you have a VAV system, for example, it's pretty simple. You have the zone airflow readings through your control system. So you can easily program minimum airflow rates and feel pretty good that we're properly ventilating each zone. If we don't have that type of system, where we actually have live zone airflow data, then we can start by taking a sample of zone or space readings and get a rough idea of how we are doing. If we wanted to go one step farther, we could go through all the zones, take airflow measurements, and adjust airflows to match calculated 62.1 air quantities. So I know that's a lot, but the approach you take, it is going to depend on quite a few factors, but there's reasonable ways to customize the approach so that you can at least get a good approximation of ventilation and get things at least that baseline. Okay, now one final thing worth considering related to all this, meaning related to controls and ventilation rates and so forth. You may want to consider how you can implement an enhanced indoor air quality mode of operation. And notice I'm not calling it pandemic mode or COVID mode, but it can be something that's broader than that, because it might apply to any number of future scenarios where you would want to have an emergency mode. So we're working with one of our clients right now and doing just that. We're writing new sequences of operations that will bring in more outside air when the systems can handle it. And we have some things built in to account for that, watching temperatures, watching equipment capacity. So doing it when it makes sense, doing it when it's most cost effective, that's something to look at too. We bringing in more outside air is good, and that's an effective measure. But we also have to consider the utility bills that keep coming, and you may have sustainability goals that you're trying to meet. So we want to be smart about how we can do this. But we don't have time to get into detail here. I do want to mention that one of the recommendations during an emergency, or we've called it also an enhanced IAQ mode, is disabling demand control ventilation. And that's something I believe ASHRAE would recommend as well. Instead of allowing, for example, carbon dioxide sensors to bring ventilation rates down when they're satisfied, then if you can eliminate that during an emergency or a mode where you're trying to increase ventilation, rates, then that's going to give you a higher overall ventilation. Now, before we wrap up with sharing numbers for implementation costs of various measures, I want to just quickly mention that Fishbeck recently completed a UV study for a Michigan hospital where surface and airborne treatment systems were analyzed. And in that study, we reviewed UV performance and energy usage and costs for different pathogens as indicated here. So we are looking at that, but again, notice it's a hospital and more of a critical application. We're not seeing a lot of this, very little of this in response to the current pandemic, although you may get it in more of a critical environment. Now we get to what everyone wants to know. How much does it cost? What does it look like to do these things? And I'll say that it is difficult to identify specific costs for modifications and to come up with numbers that are universally applicable to different systems. But regardless, I think it can help to have some order of magnitude basis for comparison or to establish a starting point. So we took here a 40,000 CFM unit, and we prepared this hypothetical study just to give a relative order of magnitude comparison. It's a 30% outside air, normal business operating hours. It's in Michigan. I believe this was Grand Rapids, Michigan. For energy costs, use basic energy costs for electric, steam, for humidification, overall cooling performance numbers. So just to explain the chart too, here the green bars, those are annual, it's actual annual energy costs over here on the right. So that's how much your annual energy would cost for implementing one of these. And then the blue is your first cost. And again, I point out that these are order of magnitude, it's rough, it's very theoretical. There's going to be differences. It's always going to depend on what your baseline is. The cost for the MERV 13, MERV 14 filters, those are based on going from, say, a MERV 8 up to 13 or 14. The ventilation tune-up, of course, it's going to depend on what your system's at to start. Zone adjustments, hard to say. We didn't put anything on there for energy costs. There's no green bar there because you may not actually have increased energy costs. You know, you save some from some zones, but others there's more. It just depends. But it gives you a relative idea. You can see that the humidification is pretty expensive. And if you have a humidifier already, it's worth bumping humidities up and again, getting it closer to 40% if you can. If you don't have humidifiers, installation of a humidifier is going to be expensive. First cost, it's also going to be expensive operating. But it's something you may want to consider depending on the environment that you're trying to condition. Okay, just about there today. Oh, just about there. And I'll close with this, that no matter what you do or what approaches you take, it's good to tell the story. And this is a quick one-page document we put together for a particular facility manager of a research facility we're working with. And the idea is that he can then share this with both staff and management to demonstrate what they're doing. And if you notice from the scorecard, this is just interesting tidbit from this particular building, that being in a lab environment turns out to be one of the best places to be, because that type of building, you're already set up to limit airborne transmission. For another research client, just another example, we didn't go through any exercises with them, but we know the building, we've helped them out often, and we just helped them generate some bullet points related to the features of the building that are already built into the lab and already in place. And then they can share those with people coming back to work and share those with management and so forth. So demonstrating what you're doing is an important step. Okay, I think that gets us about here. I'll just close by saying, you know, really COVID-19 is, it's new, and yet it isn't. It isn't in many ways. I mean, there's a lot of studies that still need to be done, and there are a lot of unknowns, but there there's a lot that is known about disease transmission in the air in general, and the things that we've shared today are long recognized measures that you can take to mitigate the risk from airborne disease transmission. So there's no one size fits all, but we hope you're able to take what we've talked about and think through what you should be doing with your facilities, whether it's reviewing your controls, inspecting your ventilation systems, inspecting or upgrading your filters. Should I increase my humidification set points? What about UVGI? All these different things. We want you to think about those and consider what you might be able to do. So I hope we've given you something to think about today and given you ideas toward improving the ability of your mechanical systems to limit the spread of airborne disease. So with that, I'd like to thank you for your attention today, even you multitaskers out there. And I believe we will now open it up if anybody has any questions.
Yeah, thank you, Ted and Mark. That was great information. I love the way that you presented it there and answered a lot of the basic need to knows that folks would have. I wanted to see who had the first question. You can use the chat or Q&A box. There's one here that someone has submitted. It says, what was the temperature basis for the humidity recommendations?
You want to jump in on that one, Mark? I guess I'm assuming at what, so 40 to 60% is at what temperature? That's probably just a room temperature. I'm not sure if I'm interpreting that correctly.
Yeah, I mean, we don't want to deviate from comfort ranges that we normally are used to. So we wouldn't want to, go beyond the normal set points of the, 70, 75 comfort range that people are used to, because then you're going to cause other issues. So temperature, we're not recommending, or ASHRAE doesn't recommend to deviate from what your normal comfort settings would be for an indoor occupied space.
So there could be here, Mark, where the question is coming from, well, can I increase that relative humidity by decreasing my space temperature, which would accomplish that, right? And what we're saying is you'd still want to stay within your temperature ranges because you could be causing other problems.
If we're talking about a space that is occupied by humans, yeah, we want to we don't want to concern about comfort as well. So.
Okay, that may be very helpful for what the question was. I might also wonder what the difference would be in Michigan here. We're talking July now, looking ahead, outside air temperatures going to, all through the winter. And will that change, in terms that you say you want to maintain the interior and indoor air comfort levels and things? Obviously, you've got a lot of utility considerations then once the temperature drops, and that would all be made up.
Yeah, and you saw on the slide with the relative cost, it was close to the end here. Could even go back. It is to increase to 40%. That is a big energy cost to do that. If you can get, and there's different, if you can get even 30%, even through, I know it's not within the 40 to 60%, but if you can even get to 30%, as we get in the winter here, and you get in the dead of winter and it's 0 degrees out, 10 degrees, 20 degrees, I mean, you'll start seeing your building relative humidities typically without humidifiers getting down to 20% or less, maybe even less than that. But every little bit you can do with that is going to help here. And there's some charts, I believe Mark ASHRAE has published some charts on that are helpful. But if you can do as much as you can do with that is good.
Great, thank you. Another question is, do the air change recommendations vary when you're considering industrial space like an open warehouse with extremely large volume there as opposed to an office environment?
Yeah,
Yeah,
I think, go ahead, Ted.
Yeah, I was going to say yes. Yes, the recommendation. Well, yeah, the air change recommendations. Those can definitely vary, and you can still have controls that modulate. I think you can still do that with a large open volume. You know, and if you're talking to bringing 100% outdoor air, that could be quite a bit. And there's recognition of that. You know, that if we bring in outside air, a lot of outside air all the time, or even just when we're occupied, we're just pumping in so much air that it's just going to kill us on energy. And I think there's recognition of that. So you do have to look at these on an individual basis and look at your buildings and your specific spaces that you're trying to condition. But yeah, I would say there's still opportunity to vary airflow. Anything to add to that, Mark?
I would just add, like, in a tall space, I mean, you were primarily concerned about where people are. So I'm not sure what type of space we're talking about, but if people are on the ground floor, you might start looking at, well, where is air being introduced into that space and where is it being removed? Because we're really concerned about, that bottom 7 feet where people are. If it's different levels, then it's obviously a different question. But so really the most important thing in a big space would be looking at that area where humans are occupying the space.
Mm-hmm.
No, very helpful. Another question was, are you seeing any delays in the supply chain on replacement filters with MERV 13 or higher?
Yes. Milk filter manufacturers are in the limelight. We talked to, Camfil is one of the premier companies in the world, and they are definitely, pumping out filters like you wouldn't believe. So yeah, it's definitely there's a delay normally than there would be without this, going on. So yes, there is delays.
Okay. Some of the questions we would have is, what are your thoughts on installing bipolar ionization?
I can take that one, Ted. These devices, they have high voltage electrodes that create reactive ions in the air that react with airborne contaminants, including viruses, so they can be filtered out. So for COVID, one question is, does the device add particles to the air that act to spread viruses? The devices are known to require multiple recirculation passes to achieve the effectiveness published in most manufacturers' product literature. Now, most of their results are from small chamber tests, so they require many passes to get the cleaning that they indicate. However, many experts believe that a cleaning device should perform well in a single pass test, because if it's used in a critical application where contaminants are constantly being reintroduced, we can't wait for all these multiple recirculation passes. So, some systems range from ineffective to very ineffective to very effective. However, ASHRAE indicates that convincing, scientifically rigorous, peer-reviewed studies don't currently exist. So our position agrees with ASHRAE. Due to the many unresolved questions, ASHRAE does not comment on ionizers because of the lack of scientific data to show whether they work effectively without introducing other issues.
So to clarify, Mark, I don't know, probably maybe everybody doesn't know what we're talking about here. Could you just comment on that in general? What kind of device are we talking about?
Yeah, from what I understand, like I say, they're high voltage electrodes that they create these ions. So the ions go into the air and then they try to attract other particles so that they can be filtered out when they get back to the unit.
Right. And where do you install a bipolar ionization system?
It would be back in your mechanical system so that it could, distribute those ions into the system.
Right.
Thank you both for that. helpful explanation, and there is a lot of new things being marketed out there, so it's always best to look at the science and the data if it's something that's going to be effective and worthwhile pursuing. Another question is about the facility and whether their existing HVAC system or individual units may not be functioning or in poor shape. What would be your recommendations for standalone single units that could achieve the optimum air quality, something on a temporary basis without overhauling the whole system?
So if I understood the question right, it's you have some systems that are just in bad shape and you need to do something right now to get by, and maybe looking at some level of unitary equipment. I think there's various ways you can do it. If you go down, if we're talking really small equipment, like we said with fan coil units or heat pumps and so forth, there can be some advantages there where you're not, again, recirculating air. It's really localized, so that's good. But also be aware that probably you're going to be limited on filters, although I think there are some where you can get good filters these days, but you're probably a little more limited there. I think one of the considerations is going to be overall capacity, right? And so you may run into where if you want to run higher percentages of outside air in certain modes, or you want to say, hey, we're going to hit an emergency mode or an enhanced IAQ and bring in more outdoor air, you may either live with not always meeting your temperature and your comfort conditions just because of the size of equipment, or you may say, well, really, I need to increase the size. So you can probably do it with, you can do things with traditional, you can do a temporary equipment here and get by with traditional equipment, whatever that may be. But I think you do want to pay attention to those details and filters, ventilation, and what kind of capacity do we need on the cooling coils, on the heating coils, if we're going to run into having increased outside air more than we normally would. So it's a design consideration, and you might want to bump up the capacity if you think that you're going to run at higher outside airflow rates. Anything to add, Mark?
No, I think that you covered it pretty well.
All right, I've got one more question here, and we'll see if there's others that folks would like to submit. And that's about your control system. You showed a lot of what can be done, and you were looking at some of the programmable options there. And but what if you do not have a central control system, only manual stats or local RTU controls?
Think about installing a control system. That'd be good. That'd be good for multiple reasons, not just for the present situation and even just for the things we talked about today, but other energy reasons, controllability, and probably comfort too, and maintenance, being able to look at things. But no, I think you can still take a look at those. It's just probably going to be more difficult to do that. If you have local controllers, you can probably still get in, and if you want to change some programming and then make some adjustments there. If you just have more of a, if you're operating with a local thermostat, there'll be some things that are harder to do, and it depends on how many you're talking. If you're talking about a whole building full of just simple thermostats, that's going to be a lot of work to go through all of those, and also just to stay on top of it and to watch and monitor. You can do it. You can make some adjustments there to some level. But yeah, I think long term it'd be good to consider what kind of central control system you have. I mean, the benefits there will long term far outweigh the cost of making an upgrade like that.
Okay. One other question, and that's regarding offices. With so many offices and people being work from home, a lot of the discussion here is focusing on increasing ventilation things in occupied spaces. But what have your clients or anybody you've seen been doing in terms of just maximizing the savings and adjusting for offices that may be empty and unoccupied most of the time.
Mm-hmm. Yeah, I believe ASHRAE even has some recommendations there about running units. I don't know what those specifically are. Mark may know. You can chime in if you know what those are, Mark. But I do think that there's some recommendations to, even if you have buildings unoccupied, run systems periodically. Our own building, we ran into the same thing where, okay, now we're working from home, and what should we do and how do we do it? So our headquarter office building in Grand Rapids, let's still run, we have a distributed heat pump system. So we said, let's still run our heat pumps in an unoccupied mode. So you're not just completely shutting them down. So they'll still work to maintain setback temperatures, either lower in the heating mode or higher in the cooling. But we did then shut off our ventilation air systems, and this is going back ways at the beginning, while we didn't have people there, but we still kicked those on and let those run periodically. It'd be like maybe an hour during the middle of the day. And that's with nobody there. And that's where I think I mentioned the ASHRAE checklist. If you're coming back, because they recognize that people are going to shut things down, and you should be if you don't have anybody there. But when you come back, okay, let's get things running early, start it up, get the building flushed out, get enough fresh air changes in there, and also give you opportunity to see what's going on with the spaces.
Yep, and even lighting systems can be, if no one's there, you can not let lighting systems run in an occupied mode.
Hmm.
Well, I think that's it as far as the questions we've got submitted, and we're just for the top of the next hour. So I wanted to thank everyone again for the questions that were submitted. Thanks again to Ted and Mark for the great presentation. We will have the recording of the webinar available for those who participated, and also for those who weren't able to make it. And I think we'll check with you whether we can share the slides with those who were on the webinar too.
Well, very good. Thanks for having us. Really appreciate the opportunity to do this.
Thank you for your time and for your sponsorship. And I also wanted to then just lastly say that our next webinar in the series will be on Thursday, August 6th. 2 weeks from now, we are going to be featuring an entirely different topic on drones and what facility operators should know about drone technologies and regulations. So for critical manufacturing, how do you keep your employees safe, and how do you deal with security concerns of things in the sky? So that should be really novel, and look forward to learning more about that. And you can register already and share the information with your colleagues if who may have an interest in that topic. So thanks again. Have a great rest of your day. Stay safe, stay well, and thank you for joining us.